So I want to show this limit. I want to show that the limit as x approaches 1, 3x plus 2 equals 5. And I want to do this using the formal definition, the epsilon delta definition. Okay, so that the definition has a few parts. So just to kind of map those parts to our question, this 5 in the definition, that's usually the letter L, that's the actual limit. This 3x plus 2 is the function f of x. And this 1, the number that x is going to, usually that's the letter A. You may see some other things, but I'm going to go ahead and use A. So what the definition says is that for L to be the limit, for every x that's within delta of A, but not equal to A. All right, we don't want to let it actually get all the way to A. That's what that greater than 0 part is saying. We must have the absolute value of f of x minus L. That's the distance from the function value to the limit, has to be less than epsilon. All right, so let's put our values in here. So what I'm saying is, for every x, for every number whose distance from 1 is less than delta, then the distance from 3x plus 2 to 5 has to be less than epsilon. I have to find a delta that guarantees that this is going to happen. All right, and the way we do this is we kind of do it a little bit backwards. Okay, I'm going to actually start over here on the then side of this with this expression. Right, because if I simplify this a little bit, I get the inside here, this is 3x minus 3 is less than epsilon. And if I factor out that 3, now be a little careful. This is, I have to factor out the absolute value of 3 times x minus 1 is less than epsilon. Now, yes, the absolute value of 3 is 3, but if that had been a negative I was factoring out, you'd have had to be a little more careful with it. So that's just 3. I'll divide both sides, and we get the absolute value of x minus 1 is less than epsilon over 3. Okay, so this is my formula, right? What this is telling me is that if I choose my delta equal to epsilon over 3, then I know that every number that's closer to 1 than that amount is going to give me a function value that is closer to 5 than epsilon. Now, this is the point where a lot of textbooks stop, right? And that's a little unfortunate because we haven't actually proven the limit yet. We've found the value of delta that we need to prove it, but we aren't actually done. Right? So here's how I'm going to do the actual proof now that I've got that expression in my hand. All right, so what I've got here on the left side is just the steps from the previous slide. Right up here, this is where I did f of x minus L, and then we went through all of these steps, and we got this formula here. Right, so what I need to show is that if the absolute value of x minus 1 is less than epsilon over 3, then the absolute value of 3x plus 2 minus 5 is less than epsilon. And you can do this just by walking through these steps backwards. Right? So if the absolute value of x minus 1 is less than epsilon over 3, then 3 times the absolute value of x minus 1 is less than epsilon, which means the absolute value of x minus 1 is less than epsilon. Whoops, sorry, I went the wrong way. I need to bring that 3 inside. So now this is the absolute value, and I can only do this, mind you, I can only do this because that 3 is positive. The absolute value of 3x minus 3 is less than epsilon. Now here comes the really kind of tricky stuff. I've gotten to this line here, and I need to go to this line here. So I'm going to split that minus 3 up, make this the absolute value of 3x plus 2 minus 5 is less than epsilon, and that's what I needed to show. This is the function, and this is the limit. So I've shown that if you pick the epsilon, right, you pick some epsilon greater than 0, I'm going to pick epsilon over 3 to be my delta. And what I've shown is that if for every value of x, that is within this distance of 1, the distance from the function to the limit has to be less than your epsilon.